Now we begin the dynamics section of our mechanics. The first part is kinematics of particles, and the first part in kinematics is rectilinear motion. Motion along a straight line is rectilinear motion, and motion, the second part is curvilinear motion, where we'll study motion around a curved surface. For now, we'll focus here. Particle. Particle here doesn't mean a very negligible mass, point mass kind of a substance. Particle here means a body whose motions we are going to study. Some basic terms that we are going to use is, first is position. Position is given by points say x or y. These are small letters. Uh, the convention says that if your starting point is say here O, and then the position here x in positive x direction or to the right of origin is taken as positive, and to the left of origin is taken as negative. And these are some of the conventions that we will see when we solve sums. The next part is displacement. Suppose we are here at a starting point say A, and we move to a point B. So the displacement is given by uh, the total change in the position of the body from the initial position to the final position. Even if this is the path followed for the motion, the overall displacement is still given by this straight line. It is a vector quantity, whereas distance is a scalar quantity. So when we calculate distance from one point to the other point, the entire path traveled is taken under consideration. So these are some very basic points. The next one is velocity, and an important point. Velocity. Velocity is defined as change in the position dx, where dx represents that dx is x2 minus x1. So change in position by dt, which is the time, which is difference between initial and final time. So that would be t2 minus t1. So this is dt. So this is how we represent velocity. Change in displacement per unit change in time is velocity. The next term is acceleration. Acceleration is defined as dv by dt, which means changing velocity to the change in time. Change in velocity could be, suppose we have, or we consider a ball, and there is a ball here, and we drop the ball from here. At initial stage, the velocity is 0. This is the initial velocity, u. And at the final stage, when it reaches ground, the velocity is taken as v. In the time it is traveling down, an acceleration g equal to 9.8 in downward direction is acting on this ball. So the velocity of it increases at every instant, and hence we find this change in velocity as change in velocity with the change in time gives us acceleration, and for the normal acceleration due to gravity is given by 9.8, and this is constant value. But suppose we are pushing the ball with some velocity, we are not dropping it, we are actually pushing it down. So this initial velocity will not be zero. It will then start with some velocity u, or you can, for our case, we can take it as u1 and will come down with a velocity v2 or v1. So these are some of the things that we need to take care when we solve sums. Then we have the kinematic equations. The first one is v is equal to u plus at, where v is the final velocity, u is the initial velocity, a is acceleration, and t is time. This equation gives us, or this equation represents the velocity in terms of, or velocity as a function of time. The second equation is S is equal to ut plus half at square, where S is displacement, u is initial velocity, t is time, half into a is acceleration, and t is again time. And this equation gives us the, it is displacement as a function of time. So now we have the third equation. This gives us actually the velocity as a function of displacement. So this is a new one. Velocity as a function of displacement. V square equal to u square plus 2as. This we might have studied earlier as well, but this is a completely new equation. For us, again, we'll take the same case of ball falling downwards. What if we have to find the distance that the ball has covered in, and suppose it takes, this is 0 and it takes 5 seconds. What is the distance that it traveled in the third second? So for such calculations, we use this formula dn, where n indicates the nth second for which the calculations are being done. So it is actually Sn minus Sn minus 1, which means this it is distance traveled in nth second is given as distance traveled in n seconds minus distance traveled in n minus 1 second. So for when we calculate, when we solve the questions regarding this, this is the formula we'll use. dn is equal to u plus a into n minus half, where n is the nth second, u is the initial velocity, and a is the acceleration.